Hello all, this is Dr. Sudhakar. In this video lecture, we are going to see the fundamentals of fluid mechanics and hydraulic machinery. Before entering into the topic, first we have to know the definition of fluid. Fluid Fluid is a member which undergoes continuous deformation under the action of shear stresses. How the shear stress will be acted on the fluid due to the uh, arising of forces shear forces. Okay, let's take, like, consider a fluid like this. Now due to the shear stress, this fluid will be continuous deform under the action of shear stress. This is the definition of fluid. Fluid is furtherly classified into two types. One is liquid and one is the gas. Based on their molecular structure, this liquid and gas will show different characteristics. So what is the meaning of molecular structure? So the in the molecular meaning of molecular structure is spacing between the molecule to particle to particle. Okay, so let's consider a gas. For gas, example is air. So in air, just consider a structure of the gas. Let's consider, assume this is the structure of a gas. In this air, the position of the particles are like this. So here you observe the space. If observe, the space between the particle to particle is more. So due to this, these particles can move randomly in any direction. Okay, so based on this molecular structure, this liquid and gas will produce the different characteristics. So generally, the spacing is more in gas. Okay, weak in liquids and very strong in means spacing based on the space, the molecules will move freely. Due to in gas, the space is more, so there is a more freedom for the particle movement in gas. Very weak in liquid and solid is there is no gap. It's a compact structure and means rigid structure, so it's a very strong. So based on this, we can say solid is the strength of solid is greater than the greater than the liquid, and for coming to liquid is greater than the gas. So this is the relation. The strength of solid is greater than the liquid, and the strength of the liquid is greater than the gas. So solid is the strength of the solid is compared to liquid and gas is more based on this molecular structure, because solid is a rigid structure. Okay, but as per our subject, we are going to see the fluid. So just now I said the fluid is a classified into two types. One is liquid and gas. So we can apply this knowledge in designing of structures, hydraulic structures, nothing but dams, canals, vies, and also, well, designing of a machinery, nothing but pumps, turbines, etc. Okay, and this knowledge is useful in pneumatic and hydraulic devices. Okay, and the design and analysis of gas turbines, rocket engines, and aircrafts. And this knowledge is very useful in power generation from power generating from hydraulic steam and gas turbines. And this knowledge is very useful for measurement of pressure and velocity in a fluid devices. Now we are moving to the, up to now we have seen the definition of fluid and classification of fluid, and where we can apply knowledge of fluid mechanics in real field. Okay, now we are seeing the definition of fluid mechanics. Fluid, just now we have seen the definition of fluid. Okay, what is the definition of fluid? Fluid is a member which undergoes continuous deformation under the action of shear stress. Okay, next part is mechanics. In earlier classes already we know the definition of mechanics. What is meant by mechanics? Mechanics is a branch of science which deals with the effect of forces acting on the, or which deals, or we can study the effect of forces acting on the body. The body may be in a rest or it may be in a motion. Okay, similarly, similar definition now we'll see for fluid also. That is the fluid mechanics. So fluid mechanics means, fluid mechanics is a branch of science which deals with the behavior of fluid. Behavior of fluid means liquid and gases at rest as well as in motion. Okay, to know the behavior of the fluid when it is acted upon by some forces. So here we are talking about fluid. So force means which type of force we have to consider? Pressure forces. So based on the pressure, force acting on the fluid, how it is behaving, that everything we studied from the studied in this subject, fluid mechanics. Okay, so again furtherly this fluid mechanics deals with the fluid statics, kinematics and dynamics. Fluid statics, the keyword for static is rest. If you want to know the, if force acting, if you want to know the effect of the force when acted upon by the fluid when it is in rest, that is the nothing but statics. Means to study the effect of the forces, pressure forces acting on the fluid when it is in rest position is called as fluid statics. Okay, next fluid kinematics. Okay, to study the effect of the pressure forces when acted upon by the fluid, it is in motion, but for reference of motion is force. Force is the reference for motion. Okay, here we are not considering force. Without considering the force, if we consider the only motion, by considering the motion, if you study the effect behavior of that fluid, nothing but kinematics. Okay, without considering motion, only when it is in rest position, if you study the behavior of the fluid when it is acted upon by pressure force, it's called as statics. Next, fluid dynamics. Dynamics, just now I said force is the responsible for creating the motion in the fluid, okay, or body. Okay, here we are talking about fluid mechanics, that's why I am saying fluid. Okay, dynamics means now along with motion, along with force we consider the motion, because for creating the motion force is the responsible. Okay, so to study the effect of the pressure force acted upon by fluid when it is in motion. Okay, and now along with the force we will consider the motion. By considering force and motion, if you study the effect of this effect of the fluid, effect of the force and motion, how it is acted on the fluid. So fluid dynamics means the study of fluids in motion, where the pressure forces are also considered. Okay, nothing but in simple way we can say. So fluid dynamics is a branch of science which deals with the or which study the which branch of fluid mechanics, uh, which study the effect of the forces acting on the fluid when it is in motion, along with force plus motion. This is important here. Now we are moving to the properties of a fluid. In properties of fluid, the first property of the fluid is density or mass density. Okay, so we know what is the meaning of density. Before going to see the meaning, why we have to study this density? What is the importance of density? Density tells us how tightly a material is packed together. Based on the density, we measure how tightly a material is packed together. So this is the importance of density. The definition of density is defined as the ratio between mass of the fluid to the volume. That is mass by volume. So simply denoted by symbol rho. The unit of density is as per SI units kg per cubic meter. So that is density equal mass by volume. Okay. So at STP conditions, the density of water is 1000 kg per meter cube or 1 gram per cubic centimeter. Okay, what is meant by STP? STP nothing but standard temperature pressure conditions. So this is a fixed value at STP conditions. The value of liquid at STP, the value of density of water is 1000. This will for gases we can't define. This will be vary based on the pressure and temperature. The density of gases will vary. So now from this definition, we have to know the definition of the density. We have to remember definition of the density, that is density is defined as mass by volume, and for what it tells us, density mainly tells us how tightly a material packed together. Okay, and the value of density is 1000 kg per meter cube at STP condition, and value for gas will vary. Next is specific weight or weight density. It is defined as the ratio between weight by volume. Okay, so denoted by symbol small w. So I'm saying small w equal to weight capital W by volume, weight by volume. So we know the relation between weight and mass. In earlier classes we know the relation What is the relation between weight and mass? Weight and mass relation is weight equal to mass into acceleration due to gravity, that is W equal to m into g, okay, by volume. Volume means V. So just I am rearranging this term, that is mass by volume into g. So by seeing this ratio, we can, what we can write here, just now we have seen the definition of density, that is density is mass by volume. Now instead of this mass by volume, I can write the rho and into g. So this is, from this we can know the relation between weight density and mass density, that is small w equal to mass into acceleration due to gravity. So what is the relation? Small w equal to rho into g. This is small w. So you have to remember this relation, very very important. Remember this relation between weight density and mass density, that is weight density equal to mass density into acceleration due to gravity. Okay, suppose for example, sometimes they will give the weight density value and they will ask to find out the mass density. So how will you find? By using this relation, that is weight density equal to mass into mass density into acceleration due to gravity. Okay, that is just now we have seen the relation. Because we know the value of density of water at STP, at a standard temperature pressure conditions, that value is 1000. Like that, what is the density of weight density of water? Weight density of water, we know the formula, small w equal to mass density into g. What is the value of mass density for water? 1000. 1000 into g is 9.81, that is 9810 Newton per cubic meter. So what is the weight density or specific weight of water value? 9810 Newton per meter cube. And what is the value of mass density? Mass density of water, mass density or density of water is 1000 kg per meter cube. So this is the conversion. In earlier classes, in intermediate level, already we know the how to dimensional homogeneity by applying how to convert the dimensions and everything. Okay. Next, we will see the specific volume. So what is the definition of specific volume? Specific volume is defined as the ratio between volume of fluid by mass of fluid. This is just is a reciprocal of mass density. That's why I'm writing 1 by mass of fluid by volume of fluid, that is 1 by rho. Okay. So we know the unit is SI unit of density, mass density, that is kg per cubic meter. So now it's, I'm saying it's a reciprocal of specific volume is a reciprocal of mass density. That's so the unit will be cubic meter per kg. So where it will be applicable? Generally this is applicable for gas. Gas means, for gas we are considering reference as a air. Okay. Next, specific gravity. Specific gravity is denoted by symbol S, and its another name for specific gravity is also called as relative density. Okay. So what is the definition of specific gravity? The definition of specific gravity is, either we may consider weight density or we may consider mass density. Any one density we can consider. Okay. The definition of specific gravity is weight density or density of a fluid to weight density or density of a standard fluid. Here, what is the meaning of standard fluid? Suppose we know the classification of fluid. Fluid is again classified into how many types? Liquid and gas. So for gas, again we are considering reference as a air. Okay. So suppose here weight density or density of a fluid. Instead of fluid, if you consider here liquid. Here liquid means, what is the standard fluid for liquid? The standard fluid for liquid as a water. Instead of liquid, if you consider a gas, what is the standard fluid for gas? Air will come here. In denominator, if numerator we are considering a liquid, denominator water will come. In numerator, if we consider as a gas, denominator it will consider as a, the standard fluid will consider as a air. Okay. So we now we have seen the formula, specific gravity equal to either weight density or density of a fluid by weight density or density of a standard fluid. So I'm considering a density, for example, density of a fluid by density of a standard fluid. Okay. Suppose fluid means I'm considering a water or liquid, not water, I'm considering a liquid by density of water. Okay. So now from this relation we can find the any one parameter. If you know the specific gravity, by cross multiplying the specific gravity with density of water, because the density of water value is fixed at STP condition, that is 1000 kg per meter cube. We can directly find the density of liquid. Or if you know the specific gravity value, if you know the specific gravity, by cross multiplying specific gravity with density of water, we can know the density of liquid. Okay. Or if you know the density of liquid value, so by using this ratio, we can find the specific gravity. Anyone, vice versa. Okay. So for competitive exam, they will ask the like, see here, I'm telling weight of liquid is weight of density of liquid, or density of liquid equal S into weight density of water. Okay. So that is S into weight density of water, means I am using the relation between mass density and acceleration due to gravity, that is small w equal to rho into g. Okay. Unit with symbol S is a dimensionless unity. There is no unit for specific gravity. Why? Numerator is representing one same property, and denominator also representing same property. Because see here, density, numerator also representing density property only, denominator also representing density property only. So that unit, numerator unit and denominator will be get cancelled, and we'll get the unitless quantity. It's a dimensionless quantity. Remember, specific gravity is a dimensionless quantity. Okay, because both numerator and denominator is representing the same property of fluid. So what is the importance of this specific gravity? So specific gravity compares, by using specific gravity, we can compare how dense a material with the relative with the water. Compared to water, how dense a material. That is numerator, we are writing a density of a liquid. That density of liquid, how much dense with the compare with the water. That will be done. That will possible. That comparison will be done with specific gravity. Okay. So next, suppose here, see specific gravity of mercury. I am considering specific gravity value is 13.6. So remember this, density of water is 1000 kg per meter cube, and specific gravity of mercury is always 13.6. And what is the specific gravity of water? The specific gravity of water value will be 1. Remember. Okay. So suppose he given the specific gravity of value 13.6, and he is asking the density of mercury. This mercury comes under the liquid category. Okay. So he is asking density of mercury, means what is the formula? Specific gravity equal to density of mercury by density of standard fluid, because mercury comes under liquid category. So liquid means numerator liquid, means denominator the standard fluid for liquid is water. So what is the specific gravity value he given? He is given that specific gravity value 13.6 equal to density of mercury by, what is the density of water? The value of density of water is 1000. Then density of mercury equal to 13.6 into 1000. What is the final value? Is a 13,600 kg per meter cube. Like similarly for gases. Gases means weight density or density of gas by weight density or density of air. So for gas, what is the standard fluid? Air is the standard fluid. Okay. So what is the importance of specific gravity? How dense a material when it is compared with the water. Now let's say a problem. So just now we have seen four properties of a fluid. One is the density, next one is the weight density, next density or specific weight, next we have seen specific volume and specific gravity. So see, once read the statement of the problem. Calculate the specific weight, density and specific gravity of 1 liter of a liquid which weighs 7 newtons. Okay. So is asking specific weight or weight density value, density or mass density value, and the specific gravity value, okay, of 1 liter of a liquid. This 1 liter of a liquid means comes under, so fluid is a again class, we know fluid is again classified into liquid and gas. So this is a liquid category, okay, of 1 liter. 1 liter nothing indicates volume of liquid is how much? 1 liter. Okay. Then as per SI units, what is the 1 liter is converted into the value converted into cubic meter, how much? 1 by 1000. 1 liter equal to 1 by 1000 cubic meter or 1000 cubic centimeter. Okay. So 1 by 1000 cubic meter means 0.001 cubic meter. So I'm converting volume 1 liter into SI unit, that is cubic meter, that is 0.001. okay. What is the weight value? Weight he given the 7 newtons. Okay. So we know the definition of the specific weight or weight density. What is the formula? Weight by volume. We know the weight. Weight is 7 by 7 by what is volume of fluid in cubic meter? 0.001. So after calculation we got value, we got 7000 Newton per cubic meter. And next is asking density. We can find the density. Density means mass by volume. So by knowing the mass we can find the density value, or by using the relation between weight density and the mass density also we can find this density value. Okay. So here I am using the relation between weight density and mass density, that is W equal rho into G. Okay. So what is the W value? From first parameter, that is specific weight or weight density, that is from that rho equal to W by G. The W is how much? 7000. 7000 by 9.81. How much? Say 713.5 kg per cubic meter. Okay. Next parameter is asking specific gravity. Specific gravity means it's a liquid. Liquid means what is the specific gravity for liquid formula? Either you may consider specific weight value, or you may consider density, that is density of liquid by density of water. What is the density of liquid? Just now we found, that is 713.5. Density of water is fixed value 1000. So finally we got 0.7135. So in this lecture, the conclusion of the lecture is, so first we have seen the definition of fluid. What is the definition of fluid? Fluid is a member which undergoes continuous deformation under the action of shear stress. Then we have seen the classification of fluid. Fluid furtherly classified into liquid and gas. Okay. And based on molecular structure, this liquid and gas will show different characteristics, that everything we saw. So based on molecular structure means movement of the molecules. Okay. So gas is a loosely packed, liquid is a little bit loosely packed, and compared to solid is a rigid structure. Okay. Next we have seen the by knowing where we can apply this knowledge of fluid mechanics, in which fields we can apply, that application we have seen. Main application is at dams, design of hydraulic structures, that is kind of dams, canals, wires, and hydraulic missions. Missions means pumps, motors, and everything. Okay. So and if you want to find the pressure and temperature by using the pressure devices, there also this knowledge of fluid mechanics is very, very important. Next we have seen the properties of a basic properties of a fluid. One is density, one is specific volume, specific weight or weight density, and specific gravity. And we solve one simple problem. So here density, the density of water is 1000 kg per meter cube, and weight density of water is 9810 Newton per cubic meter, and is a specific volume generally applicable for gases, and specific gravity is also called as a relative density, and it's a dimensionless quantity. The importance of specific gravity is when we compare a fluid liquid with the water, how dense it with the water, that comparison will be done with the done by specific gravity uh, value. Okay, thank you.